In this lecture, I'm going to show you how to do your quantile plots on Jupyter notebooks. We'll start by importing numpy as np because I'm going to generate some random data. I'm going to import scipy.stats as stats because I'm going to be needing some PPF functions. I'm going to import pandas because I'm going to need some data frames. I'm importing matplotlib.pyplot as PLT because I'm going to be drawing some graphs, and again including my %sign matplotlib inline to make the graphs come out better. And I'm going to be working with small samples, so I'm just going to set a sample size of 15. Any number will work here. And I'm going to be working with quantiles, so I define my quantile function. It just depends upon what sample size you're working with. I have x will be mapped to x plus 0.05 divided by sample size. So I want to get this all into my sheet, so I shift and enter, and it's in. My first example, I'm going to be working with uniform data. I'm going to take a uniform sample of the interval from between 10 and 20, and again, you NP the random uniform from A to B of the sample size, and then I'm going to put that into a data frame. Okay. In this one, I'm going to sort these values, again going from low value to high value. And because I'm going to do my quantile, I'll insert a rank column, and then I'll put in my quantile column. Okay, now I'm going to be doing my my PPF of my theoretical quantile. So I put a new column in data, uniform PPF of the quantile data. I'm going to apply stats.uniform, and remember, the stats does the uniform differently. This is the initial point of the interval. This is the width of the interval, as opposed to its end point. Okay, I don't know why they did that, but they did it. And so I will have that. Then I'm going to plot this, and so I'm going to let x be my my theoretical column, and y be my column with the actual data. I will plot a line, okay, using my x and y, and then I'll do what's called a scatter plot. I get my line with my x, and a scatter plot with my x and my y. And so the straight line here, the solid straight line, is from my plot. That's what plot does in the matlib.pyplot package. The individualized points is how scatter does it. And so here, notice that my data lies loosely around the line, not venturing too far away. Okay, so that's doing a quantile plot for a uniform distribution. For a normal distribution, okay, I'm going to generate a normal distribution, normal data from distribution with mean equal to 15 and standard deviation equal to 1.7, and I'm going to call this normal sample. Okay, using the same sample size as I did for my uniform data and put it into data frame, shift and enter. Then, having done that, I'm going to do what I did before. I'm going to sort that data from lowest to highest, and leaving it in place. I'm then going to put in my rank column because I'm going to be calculating quartiles from my rank. Then calculate the quartiles by applying that quantile function to each data item in the rank in turn. Remember rank goes 0, 1, 2, 3, all the way up to till you run out of data. My normal PF column is where I will put the theoretical values from the normal distribution, again because I'm going to be applying to that quantile column the stats.norm mu sigma dot ppf. Okay, and so again, my x contains my theoretical values, my y contains my actual data, and then the plot xy and the plot xx and the scatter xy. Let's see how this looks. And again, you know, it stays decently close to the line. Okay. Now, so again, these two pictures staying decently close. What does it look like if it misses? Okay, if it's kind of this loosey-goosey, when with an actual fit, what does it look like when it misses? And so I shift and enter, and again, here I'm a little bit low all on this end right here, and I'm a little bit high all on this end. And I'm testing the uniform versus a theoretical normal distribution. And I guess one of the things here, sometimes you can get away with using uniform data when you actually want normal data. If it fits this test and you can't tell it, it's not going to be too much different when you roll it through your formulas. That's why it's statistics and not mathematics.